Hi everyone, this is Adam again. So the last day I finished with the paper 1 video, so now I'm going to move on to the paper 2. So paper 2 is kind of probability, statistics, triangles, these sort of things will come up in it. So I'm just going to go through this book, very similar to the way I did paper 1, okay? So just for this very first video, I'm just going over statistics 1. So it's just kind of the basics of statistics. There's a lot in it, but I'm only going to cover the things that I think are actually necessary. So first of all, you have 4 different types of data. You have categorical, which splits up into ordinal and nominal. Ordinal, you can basically, tell by, ordinal. It's basically data that you can order. So it's categorical, so it's categories. So it would be something like an example would be small or large. So it's just do they have order? Can you say that one's bigger than the other, or these sort of things? Or is one better than the other? So something like for exam results, say you can get an A, B, C, D, E, or F. So obviously A is the best grade you want, or something like that. Like do they have an order? It's fairly obvious that a B grade is in between an A and a C, and that a medium is in between a large and a small. Nominal, basically you just can't order them. So that would be something like maybe hair color, or maybe like your favorite band, your phone color, these sort of things. The things that don't really have an order, you can't order them in a certain way. Okay. So the next one, so you have categorical and then you have numerical. So numerical, again, there's 2 different ways. You have continuous and discrete. So continuous data, so it's called continuous numerical data. So it'll basically be that you have an infinite number of values. That's what continuous means. So it's just continued. So there's no breaks in the data. So something like height, because you can't say, oh, I'm 6 foot, because you could be 6 foot and 0.1 of an inch, 0.01 of an inch. If you actually got very, very specific, your height would you could keep getting more and more specific. Okay. Whereas that's basically continuous data. So data would kind of be like height, something like that, So it could be something like rain as well, rain measurements. Because you would say, oh yeah, it was 1 centimeter, but it could have been 1.0001 centimeters, or so on and so on. So it's basically the number that you get can just be any real number. Discrete basically says that you can only have a certain amount of them. So that would be if I asked, how many cups of tea have you had today? You'd say 1, 2, 3, 4. That's what you'd say. So that's discrete. So shoe size as well. So it just shoe size. You can have shoe size. You can have 10, 10 and a half, 11. You can't have your shoes being like 10.375. Like that doesn't make any sense. Okay. All right. Those are your 4 different types of data, and you can be asked those. So now there are some other things that are important, but the majority of things you don't care about. Things about like collecting data, these sort of things you really don't care about. Is there what's the next thing? Yeah, so like a stem and leaf plot. Okay, so a stem and leaf plot would be something like basically that you might have two different sets of data. Say here you have the ages of girls, and say like that, and then you have ages of boys over here. They can basically ask you to put this on a stem and leaf plot. Now you would have done this in third year, but I'm just covering it again just to because I'm assuming you've probably forgotten, basically. So the way you do it is you'd say girls are on the left, boys are on the right. You basically have a section down the middle, which would be something like you would say 0, 1, 2, 3, 4, 5, 6, 7, 8. Now what you do is, I'll do the boys first because it's a bit easier. What you do is, this corresponds to the first number, okay? So the first number I see is 1, 7. So how many ones do I have? I have 2 10s and a 7. So I'm going to put 0 here, 0 here, and 7 here. Okay, so you can think of this as this being 0 plus 10. So these are like the 10s, and then these are the single digits over here. So that's basically how you write it. And you always go from the smallest number to the biggest on the right. So it's always, the further you go away from this, kind of the stem, then that's what you would get. So these are kind of leaves. That's the idea. And then your stem goes down the middle. And the next lowest of the boys is 37. So I go up to 3 and I put down a 7. The next lowest is 52. So I put a 5 and a 2. And then it goes 83. So I just put 3 on the last. Okay. And then you always have to write a key down at the bottom. So the key is basically saying, if you see this, so you put an example, you say, if you see 8 and then a 3, that means it's 83 years old. So the key basically tells you, how do you read this thing? So what does, if you see an 8 and then a 3, what does that mean? Okay. For the girls now, the youngest girl is 18 and then you have 19. So I'll go to the 1, I'll put an 8 and then I'll put a 9. So now see, this time we're working out. Here we were working out as well. Okay. The next youngest is 25 and then 27. So it's going to be 5 and then a 7. And then it's 30. So it's 30 and 1. And then your key, again, just give some example. I'm going to do the 1 and the 8. So if the key is, if you see 8 and then a 1, this means that girl is 18 years old. Okay? So that's just a stem and leaf plot. That's how you do those. Okay? And then that's it. Okay. So another thing that I'm going to do is histograms. So a histogram, how do you draw a histogram? So let's say we have a table like this. So something like this, okay? And it's 0 to 10, 20, 20 to 30. I'll just do 30 to 40. And I'll leave it at that. So you'll be given a table like this. And then down here, they'll basically tell you how many of them you have. And then to do a histogram is just a pie chart, but with no gaps. Okay, so you would have time down here. So here would be the 0 to 10. Here's the 10 to 20. (20 to 30), and then 30 to 40. And then up here would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you just draw in how many there is. So there's 4, then there's 9. So we'll go up here. And then there's 7. Like that. Sometimes you also write these on top just to say how many of them you have. So it's just easier for the person who's viewing it to see. But that's all you need to know, that a histogram is just a bar chart with no gaps. Okay. So like so. And the next thing is just skewed data. So if you see data like this, you'd say this is symmetric distribution. So just if your histogram looks something like this, you can just say that it's symmetric, okay? Because the left-hand side here is roughly the same as the right-hand side here. Now, if you have something like this, like this one, then you would call this, it's skewed left distribution, or you would simply say it's negative skewed, negatively skewed distribution. Basically because it's just skewed to the left, okay? And then you can probably guess if it's the opposite way, like this, then this would just be a positively. Or it could be skewed. A skewed right distribution. So that's just how you would describe the different charts like this. Okay, so this one you'd say is fairly symmetric, the one that we did. Or maybe you would say it's skewed to the left because these two are far less than these two. Okay, but or negatively skewed, but you definitely wouldn't say that it's skewed to the right. Okay, so you can be asked that in an exam sometimes. Okay, so just to be careful with that. Okay. One of the last things in this chapter might be the last thing that I'll do here, but it's basically the correlation coefficient. Okay. So the correlation coefficient, which is R, basically it goes between 1 and -1. And basically, if R is equal to 1, then you have a strong positive correlation. If R is equal to something around -1, then it's a very strong negative correlation. If R equals 0, then there's no correlation. Okay? So what does correlation mean? If two things show correlation, basically what that means is that if you change one, you can infer how the other one is going to change. So let's say, just think about it maybe with height and shoe size. Would you expect them to be correlated? What does that mean? That means that if I told you someone was taller, would you expect them to have a larger shoe size? Yes, you would. Is that true for everyone? No, it's not. But it's one of those things of you'd say they would have a strong positive correlation because if one goes up, the other goes up. If you have someone who's 5'2" versus someone who's 6'3", you'd expect that the person who's 6'3" would have a bigger foot. That mightn't be the case at all, but you would just expect, on average, that would be the case. Okay. So basically, if you have something like this, so this could be height, this could be shoe size. You'd expect it to kind of look something like this. Maybe a couple of things here. These 2 points here would be called outliers to the rest of the data, because if you look at the data, it kind of follows a path like this. So is this a straight line? No, it's not. The data isn't. But does it look very similar to a straight line? Yes. So basically, if height increases, shoe size increases, then R is going to be greater than 0, and it's going to be close to 1. So it could be something like R is equal to 0.8 or 0.9, because this is very strongly correlated. It's basically a measure of, if R is very positive, you can just be like, okay, that means that if one increases, we can be fairly confident that the other will increase. Okay? Some things that would be negatively correlated would be how fast a car is going, and then fuel efficiency. Because you'd expect that the faster you're going, the less, the faster you're going, the less efficient you're going to be with your fuel. Okay? So then this would give you a correlation coefficient of negative. Okay? Now, something that would have absolutely no correlation, so you can pick absolutely anything. You know? You could say something like height and how many hours of sleep people get, because you'd expect it to be something like this. That it would just be completely random. That there wouldn't be any positive correlation and there wouldn't be any negative correlation. You'd have nothing. So here, you'd expect that R would be around 0. So these things here, that basically means approximately. You'd expect it to be around 0. Okay, so it mightn't be 0, but it'll be around 0. Okay? So that's basically all the correlation coefficient is. And you can be asked on the data, they could ask you, okay, what you expect R to be. So you'd expect something like, say this. So this would have quite a weak correlation. So for this, maybe R could be around 0.4. Because you're saying, yeah, it is going up, but it's not very, like you've 2 people here who have the same, say, height. One is way below this, and then one is way above it. So you can't be certain. It is kind of obvious that the whole data is kind of going up. The whole thing is kind of going up this way. But that doesn't mean that, it's still not like perfectly correlated. So like perfectly correlated data would quite literally be like this. That would be R equals 1. Because it's just a quite literal perfect straight line. And then if it's scattered an awful lot, then it won't be half as perfect. Okay? All right. I think that's everything in the first bit of statistics. So yeah, I think I'll leave it at that. The next chapter then is going to be the first bit of probability. Okay, so yeah, I think I'll leave it there. Thank you very much for paying attention, and I'll see you in the next video.